Okay, now we're going to discuss global warming. Ooh, it's getting hot in here. Global warming. And what does your book say? We're on page 225. Now, we looked at some of these things in the last lecture video. You might want to look at that picture right there on page, what is that? 225. And it shows you what you need to know. Now, the next one says, global warming. Most of the sun's energy reaches the earth. That's right, it sure does. After passing through the atmosphere, part of the energy is absorbed into the surface and converted into heat energy. The earth is now warmed by the sun and radiates earth back into the atmosphere. Naturally occurring gases and tropospheric pollutants can interfere with this, okay? Carbon dioxide, water vapor, all of these things can absorb, reflect, or refract Earth's infrared radiation and prevent it from escaping. These are called greenhouse gases, okay? This is called greenhouse gases. In fact, the greenhouse gases or greenhouse effect is almost interchangeable. These gases slow the Earth's heat loss, making the surface stay warmer because these gases don't let the heat back out. Now look what it says. This warming process caused by the atmosphere's absorption of radiation from the greenhouse effect causes global warming. Oh, I don't believe in that. I don't know what's going on. What you talking about, man? I don't care about your politics. I'm just telling you how this happens. Okay, it's the science of what actually happens, whether it's too much, too little, is happening in a bad way, is not happening. That's for you to go figure out. I'm just telling you how it happens. Okay, now total equivalent warming impact. What is that? Well, when you take global warming, the GWP, that's global warming potential, it is, your book says, measured by comparing carbon dioxide, which is number one, okay, while they rate everything else by carbon dioxide. You're like, oh, I don't know what that means. Well, what do you think the food is that your body absorbs the most? Well, there is one food, and your body absorbs it above all others. So it is the standard of 100% absorption. That is called egg. All the other proteins, meats, fishes, everything is under that. They rate that as the number one thing, 100%. Well, that's what happens here with carbon dioxide. Look what it says. So the next time you go over there to the vitamin store, and they trying to get you to buy a $40 can of soy protein, just go eat some eggs. Don't fry them up. Just cook them in a healthy way, like boil them. Man, that's where the protein's at. You got all your amino acids in there too. Now, carbon dioxide is the number one contributor to global warming. Number one, carbon dioxide, the number one contributor. So it's got the designation of 1. That'll be on the EPA. Human needs have increased that amount by 25% in excess of what we normally have. And your book's got a little picture right there. I don't know if they got it on here though, let's see. No. But they do have a little picture of how it's working right here in your book. You can see the planet and the gases and everything, the sun. The sun's the bright thing shooting all the radiation down. Now, the more efficient your equipment is, the less electrical energy is needed to run it. Now, most carbon dioxide is a byproduct of creating energy. So your book says air conditioning equipment with a relatively small charge that never leaks only has a great, leaks may have a great impact of global warming if it's undercharged, overcharged. Now why? Well, if it's undercharged, it loses cooling capacity. It has longer run cycles, which you need to buy more energy to run it. That energy, where it's being produced, is causing the GWP to go up. But what about overcharged? Overcharged units cause you to have a loss of cooling capacity. They also cause higher head pressures and a higher amperage draw in the compressor, which causes a higher GWP because longer run cycles mean you have to buy more electricity to run a unit to try to cool down your house. So undercharging and overcharging units are indirect causes of global warming. The indirect effects are what concern scientists. Even though some newer refrigerants do not contribute to ozone depletion, they can contribute to direct and indirect global warming. So what are some of the things here? Let's take a refrigerant like 134A. Okay, that replaced R12 in a lot of systems. It has a zero ozone depletion. Zero. There's no chlorine in R134A. So it does not deplete the ozone. However, it does have a GWP rating. So just because something doesn't have a ODP doesn't mean it doesn't have a GWP. Okay? So let's get that straight real quick. Now, here are some things listed on the bottom of 226 that's causing problems. Dirty condensers, dirty evaporators, incorrect refrigerants, mixed up refrigerants, inefficient compressors, and wrong TXVs, and on and on. You can read that list. All of those things right there are leading up to global warming potential. Now, the next phrase at the bottom of 226 is TEWI, and you need to know what that means. Total equivalent warming impact takes into consideration both direct and indirect global warming effects of refrigerants. Refrigerants with lowest global warming and ozone depletion potentials will have the lowest TEWI. I'll say that again. Refrigerants with the lowest GWP and ODP have the lowest TEWI, which is the impact of both those together. 134A, zero ODP, but it does have some global warming potential. Okay, you got that? Now next we'll get into what refrigerants are.